Today we are going to discuss about stack and queue. Stack is a linear data structure that follows a particular order in which the operations are performed. The order may be LIFO last in first out or FILO first and last out. LIFO implies that the element that is inserted last comes out first, and FILO implies that the element that is inserted first comes out last. There are many real-life examples of a stack. Consider an example of plates stacked over one another in the canteen. The plate which is at the top is the first one to be removed, that is, the plate which has been placed at the bottommost position remains in the stack for the longest period of time. The following are some common operations implemented on the stack: insertion and deletion. Insertion is also known as push operation and deletion is known as pop operation. Push operation: when we insert an element in a stack, then the operations is known as a push operation. If the stack is full, then the overflow condition occurs. Push operation involves a series of steps. Step 1, checks if the stack is full. Step 2, if the stack is full, produces an error and exit. Step 3, if the stack is not full, increments top to point next empty space. Step 4, adds data element to the stack location where top is pointing. Step 5, returns success. A pop operation may involve the following steps. Step 1, checks if the stack is empty. Step 2, if the stack is empty, produces an error and exit. Step 3, if the stack is not empty, access the data element at which top is pointing. Step 4, decreases the value of top by 1. Step 5, returns success. Is the topic clear?
Yes, ma'am.
Okay. So let's move to the next topic. Queue. A queue is defined as a linear data structure that is open at both ends and the operations are performed in first in first out (FIFO) order. One of the applications of the queue in real life is people on an escalator. Queue operations may involve initializing or defining the queue, utilizing it, and then completely erasing it from the memory. Basic operations involves insertion and deletion of an item from the queue. Let's see the steps involved in insertion. Step 1, check if the queue is full. Step 2, if the queue is full, produce overflow error and exit. Step 3, if the queue is not full, increment rear pointer to point the next empty space. Step 4, add data element to the queue location where the rear is pointing. Step 5, return success. Now let's move to the steps involved in deletion. Step 1, check if the queue is empty. Step 2, if the queue is empty, produce underflow error and exit. Step 3, if the queue is not empty, access the data where front is pointing. Step 4, increment front pointer to point to the next available data element. Step 5, return success. Queue, as the name suggests, is utilized when you need to regulate a group of objects in order. So our topics are complete. Do you have any doubts?
No, ma'am.
Then can you explain what is queue and what is stack?
Stack is a linear data structure. It is also known as last in first out type of list. All the insertion and deletion is done from the top of the stack. The last added element is first removed from the stack. The operations performed on stack are push and pop.
Okay, now explain about queue.
Queue is also a linear data structure in which first element is inserted from one end called the rear, and the removal of existing element later placed from the other end called front. It is also known as FIFO, first in first out. The first element inserted into the queue will be the first one that will be deleted.
Very good.
Thank you, ma'am.
So tomorrow we will move to the next topic, circular queue. Thank you.